Esters are functional groups produced from the condensation of an alcohol with a carboxylic acid and are named based on these components. Esters are a functional group commonly encountered in organic chemistry. They are characterized by a carbon bound to 3 other atoms, a single bond to a carbon, a double bond to an oxygen, and a single bond to an oxygen. The singly bound oxygen is bound to a further carbon. Any of a class of organic compounds that react with water to produce alcohols and organic or inorganic acids are esters. Esters derived from carboxylic acids are the most common. The word ester was coined in 1848 by German chemist Leopold Gmelin, probably as a contraction of the German Essigether acetic ether. According to Boundless.com, in this very depiction, R1 and R2 are both alkyl groups or groups initiating with carbon. Esters are derivative of carboxylic acids where the OH or hydroxyl group has been replaced by an OR alkoxy group. They are commonly synthesized from the condensation of a carboxylic acid with an alcohol. An ester is characterized by the orientation and bonding of atoms shown, where R1 and R2 are both carbon-initiating chains of varying length, also known as alkyl groups. Esters are more polar than ethers, but less so than alcohols. They participate in hydrogen bonds as hydrogen bond acceptors, but cannot act as hydrogen bond donors, unlike their parent alcohols and carboxylic acids. This ability to participate in hydrogen bonding confers some water solubility, depending on the length of the alkyl chains attached. Because they have no labile hydrogens as alcohols and carboxylic acids do, esters do not self-associate. Consequently, esters are more volatile than carboxylic acids are similar molecular weight. According to chemwiki.ucdavis.edu, small esters have boiling points which are similar to those of aldehydes and ketones with the same number of carbon atoms. Small esters are fairly soluble in water, but solubility decreases with increasing chain length. When esters act as fats and oils, they are not water soluble. The chain lengths are so great that far too many hydrogen bonds between water molecules must be broken. This is not an energetically profitable arrangement. Now about nomenclature. Ester names are derived from the parent alcohol and acid. For example, the ester formed by ethanol and ethanoic acid is known as ethyl ethanoate. Ethanol is reduced to ethyl, while ethanoic acid is reduced to ethanoate. Other examples of ester names include methylpropanoate from methanol and propanoic acid, and butyl octanoate from butane and octanoic acid. In the case of esters formed from common carboxylic acids, some colloquial terms are sometimes used. For example, ethanoic acid is more commonly known as acetic acid, and thus its esters are formally named with acetate instead of ethanoate in their names. The chemical formulas of organic esters are typically written in the format of RCO2R1, where R and R1 are the hydrocarbon parts of the carboxylic acid and alcohol, respectively. Many esters have distinctive fruit-like odors, and many occur naturally in essential oils of plants. This has also led to their commonplace use in artificial flavorings and fragrances when those odors aim to be mimicked. For example, we have allyl hexanoate for pineapple, boronal acetate for pine, ethyl cinnamate for cinnamon, ethyl pentanoate for apple, and ethyl nonanoate for grapes. Here we have 5 examples of ester compounds. 1, we have methylformate with the formula of C2H4O2. Next, we have methyl ethanoate with the formula of C3H6O2. Third, we have methyl propanoate with the formula of C4H8O2. Fourth, we have methyl butanoate with the formula of C5H10O2. And finally, we have methyl pentanoate with the formula of C6H12O2. And this chart was obtained from www.ivyrose.co.uk. Most naturally occurring fats and oils are the fatty acid esters of glycerol. Esters with low molecular weight are commonly used as fragrances and found in essential oils and pheromones, also found in the aroma of many fruits. Phosphosters form the backbone of DNA molecules. Nitrate esters, such as nitroglycerin, are known for their explosive properties, while polyesters are important in plastics, with monomers linked by ester moieties. Here is my 3D model of esters. That sums it up for my video, so thank you so much for watching. To close up, here is my 10-page research with the different supercarbons.
Vietnam.